Hello guys, welcome to this week's MAT136 video. We will talk about how to find a function that represents a certain power series. The question we will discuss is the following. We want to find a function that represents the following power series, sigma n from 0 to positive infinity of n squared over n plus 1 times x to the n plus 1's power. So at first glance, this seems to be a very difficult problem. But it turns out that it can be simplified to several much easier power series. And for the first step, let's look at the coefficient here, n squared over n plus 1. Notice that the top part, the degree of the top part is larger than the degree of the bottom part. And that means that we can apply long division to this coefficient and simplify the power series here. I have n squared over n plus 1. The first term on top is n. I have n squared plus n. The difference is a minus n. Therefore, the second term on top is minus 1. We get minus n minus 1, and the difference is a plus 1. And that means that the original power series can be separated into the following parts. This is equal to sigma n minus 1 plus 1 over n plus 1 times x to the n plus 1's power. So that means that this power series can be separated into the following three parts. The first part is n times x to the n plus 1's power. The second one is sigma x to the n plus 1's power. And the third one is sigma 1 over n plus 1 times x to the n plus 1's power. Now our question becomes the following. We want to figure out what are the functions that represents the following three power series. Sigma x, sigma n times x to the n plus 1's power, sigma x to the n plus 1's power, and sigma 1 over n plus 1 times x to the n plus 1's power. So how do we proceed to find those functions? And it turns out the correct thing to do is we need to rely on the only power series that we have already known, and that is 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus da da da. That is sigma n from 0 to positive infinity of x to the nth power. We want to relate number 1, number 2, and number 3 to this power series here. Let's first look at number 2 here. So number 2 looks very familiar, very similar to what we have here. The only difference is that the power for number 2 is n plus 1, and the power here is a single n. And that means for number 2, if we factor out that x, we get sigma x to the nth power, and that is equal to x times 1 over 1 minus x. So this one is pretty easy. What about number 1 and number 3? So in order to figure out the function for number 1 and number 3, it turns out that we need to consider the derivative and the integral of the equality that we have here. So first, let's take the derivative of this guy. So let's take derivative. On the left-hand side, we have the derivative of 1 over 1 minus x, and that is equal to 1 over 1 minus x squared. And then on the right-hand side, we are taking the derivative of sigma x to the nth power, and that is equal to sigma n from 1 to positive infinity of n times x to the n minus 1's power. Notice that I'm shifting the bottom part from n is equal to 0 to n is equal to 1. That means the first term of the power series is this term 1 here, and if you take the derivative of that, the derivative of a constant function is equal to 0. And therefore, the derivative starts with n is equal to 1. For number 1, we want to figure out what is the power series of sigma n times x to the n plus 1's power. And if we compare, so notice that this guy starts with n is equal to 0, but the zeroth term, since we have an n here, when we plug in n is equal to 0, we actually get n0. And this means that it is equal to sigma n from 1 to positive infinity of the same power series. And if we compare this guy with this new power series that we have obtained, the only difference is the power here. If we factor out n x squared, we have x squared sigma n from 1 to positive infinity n times x to the n minus 1. We get an exact match between this guy and this guy, and therefore we get this is equal to x squared over 1 minus x squared. Okay, so by taking the derivative of this power series, we obtained the function that represents part 1 that we want to conclude. And in order to obtain this function for part 3, it turns out that we need to take the integral of this equality here. On the left-hand side, we take the integral of 1 minus x, and that is equal to natural log, negative natural log, absolute value of 1 minus x plus c. And if we take the integral of this power series, so okay, if you just write down what is the integral of each term, and we get sigma n from 0 to positive infinity of 1 over n plus 1 times x to the n plus 1's power. Matching those two together, we get that this power series is equal to natural log absolute value of 1 minus x. So here, I'm getting rid of the plus c here, and the function I put on the right-hand side needs to satisfy that the function, when we plug in 0, is equal to 0. The reason is that the power series on the left-hand side, it starts with, so the first term of the power series on the left-hand side is x is 1 over 1 times x to the 0 plus 1's power. So that means the power series on the left-hand side doesn't have a constant term in it. And therefore, for this equality to hold, we need that the function on the right-hand side satisfies f0 is equal to 0. And natural log 1 minus x does satisfy those properties, so we don't need to care about what plus c we put. And for the third part, we want to figure out what is this power series. And yeah, this is exactly what we find. This is equal to natural log, negative natural log 1 minus x. So let's look at what we have already obtained. We apply long division and separate the original power series into the following three pieces. We also obtain the function that represents those three power series. Therefore, for the final answer, we just need to put all the pieces together. We get x squared over 1 minus x squared minus x over 1 minus x minus natural log 1 minus x. Okay, so I have an exercise for you guys. The exercise is to find the function that represent the following power series. Top power series is sigma n from 0 to positive infinity of n squared times x to the nth power.